All right, this is quarter 3, week 1A skill practice. Here we go. So 10 to the negative 4. It's not going to have a 4 in it. It's not going to be negative. It's not going to be 10 to the positive 4. It's not going to be 10 times 10 times 10 times 10. So it's going to have 4 zeros in front, or 1 over 1 with 4 zeros, or 1 over 10 times 10 times 10 times 10, because 10 to the negative 4 is the same thing as 1 over 10 to the 4. Anytime you have a negative exponent, you can just put 1 over top and it would be the same thing. So it's these three. Excuse me. Okay, moving on. We're putting these in ascending order. These are all in scientific notation. So we've talked about how you can just first look at the exponents, and we've got that being our largest exponent, negative 2. It's only going 2 over to the left. C is the largest, A comes next. So B and D are tied with the matching exponents. So now you look at the first number. 5 is bigger than 2, so B is going to come front. And I've got a video, 7.1b, explaining this in more depth if you want to check that out. All right, we're going to keep going. So I'm going to make all of these into decimals, negative 0.34. Hopefully you know by now the trick for 11ths, multiply the numerator by 9, negative 0.27, repeat. This is already a decimal, and this is negative 0.75. So hopefully you're realizing that the positive number is going to be the largest. So then I better remember my negative sign there. So we've got these three negative numbers. Negative 75 cents would be your smallest, so that's negative 3/4. Then we have negative 34%, and then negative 3/11. All right, here we go. Perfect squares. Square root of 361 is 19. That is true. 9 times 9 is 81, so it ends in a 1. That's one way to double check it. Or you can just work out 19 times 19 and work it out. If the radical sign was around this number, it would have been good, but this is not going to be true. This works out to 10. This works out to 6. This works out to 4. Is 10 minus 6 equal to 4? It sure is. If the radical sign was over here, it would have been good, but otherwise it doesn't work. Square root of 16 is not 8. 8 times 8 is 64. If it said 4, then it would have been okay, but this is not going to be true. This is 6, this is 4, and we get 1. That is not true. Moving on. Okay, on the number line, hopefully that's a little more in focus. Okay, number line, negative 3, absolute value. Negative 3 is right here. We're going to do the distance between these two. It's 23. This shows that the absolute value of negative 23 is 23. All right, moving on. So negative 9 is equal to the absolute value of negative 9. This would become positive 9. They're not equal. This would come out positive. They're not equal. This is negative 2. This comes out positive 2.4. And this is also 0.4, and it would come out positive. They are equal. This works out to 2, and then absolute value of 2 is 2. 7 minus 9 is negative 2. They're not equal. This comes out positive. They're not equal. This comes out positive. It's not equal to a negative. So the only one that's true is this one up here. All right. 30 students in class. 20% of them own cell phones. Half of that group have Bluetooth headphones. So how many have both, a cell phone and Bluetooth? So first of all, you do 20% of 30. 20% of 30 gives you 6. Then they say half of that group. So half of 6, it's the same thing as saying 1/2 times 6, or 0.5 times 6. Hopefully you can just do that in your head and you get 3. 3 kids have the cell phone and the Bluetooth headphones. Hopefully they didn't lose them at school. All right, so this one, 9 times 1/4 divided by 1 1/2. This is a ratio table, which basically shows just a bunch of proportional relationships. So you can go 9 times 1/4 divided by 1 1/2. I'm going to use a calculator right now and go 9 times 0.25, and then I'm going to do equals and divide by 1.5, and I get 1.5, which is 1.5. Then the next one, we're going to go 3.5 times 1.5 divided by 9. So I'm going to go 3.5 times 1.5 equals, and then divide by 9. And I end up getting 0.583333. 0.583333, repeating, it just keeps on going. Now, on a problem like this, they might give you fraction answers to drag in there, and hopefully you just work out the fraction. Now, this is one where you can use a calculator, so you can just do top divided by bottom, numerator divided by denominator, and you get, this ends up equaling 7/12. That would be the one that you'd want to look at. So for this next problem, they're asking for sale price. That's going to be two operations. You're going to be multiplying, and then you're going to be subtracting. So you're multiplying and then subtracting. So first you're going to do 35% of the cost. So 0.35 times 3545. This is where Desmos calculator also comes in handy. But we're going to go 0.35 times 3545. And we get $12, and that's going to round to 41 cents because the 7 tells the 0 to go up. 12.41. So now we're going to go 35.45, and we're going to subtract the 12.41. So we get $23.04. So the 35.45 minus your 12.41 gives you $23.04. All right, moving on. If I want to know how much space a Hatchimal egg takes up, I'm looking for the what? Space is the key word here. When you're dealing with space that something takes up, you're dealing with volume. If they were asking how much plastic made the shell, then you'd be looking at surface area. All right, moving on. They're telling us these are similar. They're saying make a proportion to find the length. So I'm going to go ahead and set up two ratios, and then equal, make a proportion. I see 10 and 24 as my smaller shape. From my smaller shape, 10 is the shorter side, it goes with 15. N is the longer side, it goes with 24. So you can do 15 times 24 divided by 10, or you could look at this and say that this is going to be 2/3, and you could go 2 times 12, 3 times 12. There's a lot of different ways you could do it. Either way you do it, I'll go ahead and do 15 times 24 divided by 10. You're going to get 36. Moving on. Square. Hopefully you're remembering our little quadrilateral, trapezoid, parallelogram, rec and row, and the square. A square is all of these, except trapezoid. It's not a trapezoid. It is a quadrilateral because it's underneath. It's not a trapezoid. It's a different branch. It is a parallelogram. It is a rectangle. It is a rhombus. It is a square. Now, here's where it gets a little more challenging. Congruent diagonals. Is this diagonal exactly the same as that? Well, not the way I drew it, but yes, they are congruent. Are they perpendicular? Well, if I drew this right, they would be meeting at 90 degrees. So yes, they are perpendicular. Basically, a square's got all good traits about it except the fact that it's not a trapezoid. Pretty much everything else applies. All right, other side. Focusing in. Okay. Point B, translated vertically 12. Hopefully you're seeing vertically and going, oh, that's going to be y, and it's positive 12. So I'm going to take point B, which was originally at -1, -4. I'm going to take the y value, and I'm going to add 12. I get 8. Your new point is -1, 8. And that's the translation. Now we're going to do the reflection, the part that everybody loves. So we've got reflecting is what everybody loves. Reflecting over x. I'm going to put my finger on the x-axis, or my pencil. Point A is currently above this 1 on the x-axis. Now it's going to be 3 below. Over here, point C was 1 above. Now it's going to be 1 below. B was 1, 2, 3, 4 below the -1. Now it's 4 above the -1. Now I'm going to label my points. It was B, now it's B with an apostrophe. These are called image points now. And then you connect them. Okay, I'm going through this rather quick. Let me know if you think I made a mistake. Okay. Number cube. 18 rolls. The theoretical for rolling a 4. Well, theoretically, there's 1 4 out of 6 outcomes. So out of 18 rolls, 18 times 1 divided by 6, everything should have appeared 3 times. So theoretically, everything should have been 3, 3, 3, 3, 3, 3, 3. Now remember, this is all experimental. They're never really going to show you the theoretical. So was the experimental of rolling a 4 more or less than the theoretical? Well, its experimental was 6, and it is more than 3. Did anything actually get the theoretical? Which numbers actually resulted in the theoretical probability? Were there any numbers that we actually rolled that gave us 3 outcomes? Nope. Some kids might go, oh, there's a 3, but that's not what they're going for. This is the number 3. Did it appear 3 times? No. So none. Okay, moving on. Okay. So we're making our histogram, and then we're going to answer a question about it. So 51 to 60 is going to be these folks right here. That's just 2 of them. So I'm just shading in that box. 61 to 70. Well, that's going to be 1, 2, 3, 4 right in there. So we're just going to shade up to 4. 71 to 80. That's going to be these, but it's also going to be that 80 in the next row. 1, 2, 3, 4, 5, 6. So we're going up to 6. 81 to 90. 81 to 90 is going to be 1, 2, 3, 4. 91 to 100. So we've got these 2 and these 2. And there you go. That's that part. We're done with that. Now we're going to be, so there were no odd amounts of data. There was no like 5 people in this group or anything. That would be in between. All right, how many students scored above 80? Well, there was 4 here above 80. There was 4 here above 80. Let's double check. So there's 8 out of how many? Well, that was 2, 4, 6, and 4 and 4. So that adds up to 4, 8, 12, and then 18 out of 20. So 8 out of 20. So if you type in 8 divided by 20, you could do it that way, or you could think of this as 2/5. A lot of different ways you could do it, but you're going to get 0.4, which is 40%. So there's your final answer. All right, moving on. We're going to use the equation to fill in the table and then make the line. Now some of you might be comfortable enough to realize, hey, x plus 3, I know what that line is going to look like. I know it's going to hit at positive 3 because that's the constant, and it's going to have a slope of 1. So I could go up 1, right 1, and so let's see if it makes points in the table that follow along this line. So I'm going to think of x as parentheses, and I'd put in a -3 here, and I'd get 0. I'm going to put a 2 in here, and I'm going to get 5. I'm going to put a -1 in here, and I'm going to get a 2. Let's see if these points line up. -3, 0. Hey, look at that. It's there. 2, 5. 2, 5. Boom. It's there. -1, 2. -1, 2. It's there. They all fall on the line. No matter what you put in this table, it's going to fall along this line. It's output and then the ordered pair. I thought that was really cool when I was a kid and I had that discovery. But maybe that's why I'm a math teacher. And I think it's cool. Math is cool. All right, moving on. So this is one you could use Desmos for. I'm going to go ahead and show the process. So you have this plus 1/3 of something minus something. So n was -3, -3. M is 6. Okay, so I'm going to bring down my -3. I don't really need the parentheses anymore. Plus 1/3 of whatever this works out to. This is going to work out to a +9. So then we do 1/3 of 9. That's the same thing as saying 9 divided by 3. We get 3. Then their additive inverse, we're going to get 0 as our final answer. All right. So we're translating and solving. So the difference of means we're subtracting. The two things you're subtracting are separated by the word and. 4 times a number and 6 is -18. I'm going to add 6 to both sides. I'm going to get 4n equaling -12. Then I'm going to divide by 4, and I'm going to get n equaling -3. And there you go. And if you set up Desmos and you plug in a -3, you're going to get -18 as your answer. We're moving on. This is one where you could use Desmos and you could plug in different choices to see what gives you something smaller than 23. I'm going to show you the process. If you're looking to get into algebra, you need to understand this process. So you're going to subtract 8 from both sides. You're going to get -3n being less than 15. And I'm noticing that this is a negative coefficient. I'm going to just rewrite my final answer down here with a greater than symbol because it's going to reverse. When I divide out the -3, I'm going to get n, and that's going to be a -5. N has to be greater than -5. So all of these choices are going to work. You wouldn't want actually -5. If you put -5 in there, it works out to exactly 23, and you don't want that. You want things that are smaller. Let's put a 10 in there. Hey, that's -30. If I put a 10 in there, -30 plus 8 is -12. Yeah, that's less. That's going to work. All right. So here we go. Some of you might already know the trick for this. I'm going to go ahead and show the process. So I don't have any negative coefficients. I'm just dividing out 6, and it's not going to reverse. I'm going to get n being greater than or equal to 3. It's a solid dot, and it's going to be going to the right. When your variable's over here, you can let this do the trick of going around, or telling it which way you go. So there you go. Here I would subtract 6, and I'd get n is greater than or equal to 3. So solid at 3, going to the right. It's going to be C again, and it does say some letters can be used more than once. And then we have, here's where you got to be careful. It's a negative coefficient, so it's going to reverse. When you divide out the -5, you get n is greater than 3. Forgot my negative there. So n is greater than 3. That's open dot at 3 going to the right. So that's going to be A. Over here I would add 7. You're going to get n is less than 3. And that's going to be open dot going to the left. So that's going to be letter B. That is it. Remember, you can always check out videos explaining key concepts here. You can also visit your teacher after school. That's it. Hope it helps. Best of luck to you.